Okay, Bismillahirrahmanirrahim. We start our lecture today. Okay, for today we are looking for number theory. Okay, basically the number theory is about the integers. Okay, we start the basic principle of divisibility, modular, arithmetic, mode, GCD, greatest common divisor, and least common multiple, LCM, GCD and LCM. And then we take a look at some of the relevant algorithms that we discuss later. Okay, for the prime and great common divisor, GCD lah. Okay, this one for the GCD. Okay, for the prime number, the only have only two factors. One for itself, it can be divided by themselves. For example, we have 2, 3. Okay, we have 2, 3, 5, 7. This one is a prime number. Okay, and then prime number is a natural number greater than 1 that is not a product of two smaller natural number. A natural number that greater than 1 is not a prime is called a composite number lah. Okay, we have a natural number and 1 is greater or equal to 1 lah. Is greater than 1 lah. Sorry, it's greater than 1. Okay. Uh, okay. Other than natural number, other than prime, we call it as a composite. Composite. For example, 5 is a prime number because the only ways of writing of 5. Okay, we have 1 multiplied by 5 and 5 multiplied by 1. Okay, so far, do you have any question? Ada soalan ke? Hmm. Okay, please check my YouTube because this one is online that you need to have a lot of attention because of online teaching and learning needs a lot of revision. Okay, first of all, methods to find the prime numbers can be easily. The first step is first find the factor of the given number lah. Second step is to check the number of factor of that number, and third step is the number. If the number of the factor is more than 2, it is not a prime number lah. Okay. Okay, and then division. Division. If A and B are integers, which is integer A is not equal to 0, we can say that if A divide by B, if there is an integer C, so that B is equal to A multiplied by C lah. For example, another example is A can be divided by B lah. 3 can be divided by 12, which means that 12 is a total of 3 multiplied by 4 lah. This one is integer. Okay, we have a reminder 0 because 3 divided by 12, we have 4, 3 and 4 lah. Okay, when divide by B, we can see that A is factor of B and B is multiple of A, is dividend. And this one is integer. A is a factor, B is a dividend. Okay, notation A can be divided by B means A divided by B. We can write A multiplied by B when A does not divide by B. Okay, this one I have explained. I think I have explained this one. Disability reminder cannot be negative. Okay. Yeah, I think for today we have this one, prime and grade common divisor, section 3.5. I think this one for today. Uh, okay, we have a prime that I have explained, and then we have a GCD, grade common divisor. Okay, a prime number is a positive integer that is greater than 1. Is called a prime if the positive factor of p and are p and 1. Okay, other than integer, positive integer is greater than 1 and it's not a prime, is called composite. If you ask me whether the negative number is a prime, is the answer absolutely not. Okay, because the prime must be integer. And then this fundamental theorem of arithmetic, and every positive integer can be written uniquely as the product of prime, where the prime factor are written in order of increasing size. Okay. Okay. For example, we have 15. 15 is the product of 3 multiplied by 5 is equivalent to 15. Okay. Okay. And then we have 48. Okay. 48. We can have 2 multiplied by 24. Then we can 2 multiplied by 12. And then 2 multiplied by 6. 2 multiplied by 3. And then you can see that 2 power of 4 multiplied by 3 is the prime factorization. You list out the product of an order of increasing size, which means that you list out the number based on the uh, factors. Okay, based on the factors of the number. For example, 48, we have 2 power of 4 multiplied by 3. If 70 itself is 17, if let's say 100, okay, 100 is 10 multiplied by 10, which means that 2 multiplied by 5, multiplied by 5 by 2 multiplied by 5, and then 2 here we got 2, 2 power of 2 multiplied by 5 power of 2. Same goes to 512 lah. We have 2 power of 9 is equivalent to 512. If the question asks you to list out the prime factorization, you need to list out the order of the increasing size. Okay, another example is 72 lah. We have prime factorization. Call it as prime factorization. Okay. Okay, we got 4 multiplied by 18 and 2 multiplied by 2 multiplied by 3 multiplied by 6. And then here we can also distribute 6, 2 multiplied by 3. And then for the prime factorization, we have 2 multiplied by 2 multiplied by 3 multiplied by 2 multiplied by 3. And then you got 1, 2, 3, 2 power of 3 multiplied by 3 power of 2 here, 1, 2. Okay, so far do you have any question? Okay, please if you have a question you should ask because We only left 4 weeks time. And also please to submit your group assignment. Okay, same goes to 48. We have 8 multiplied by 6. Okay, and then we have 4 multiplied by 2, uh, multiplied by 2 multiplied by 3. Okay, this one is the order of increasing number. Okay, and then finally we got 2 power 4 multiplied by 3 power of 1. Okay, and then we got 48. Okay, for the prime, if n is composite integer, then n has a prime divisor less than or equal to n. This is easy to see. If n is composite integer, it must have two divisor. Absolutely, they must have two divisor, p1 and p2, such that p1 multiplied by p2 is equivalent to n, and p1 is greater or equal to 2, and p2 is must be greater or equal to 2. Okay, and then p1 and p2 cannot both be greater than power of n, because p1 multiplied by p2 would be greater than n. Okay, for example, if you have 3 uh, uh, multiplied by 3 is 9, and 9 uh, power of 9 is equivalent to 2 is 3 lah. Okay, would be greater than n lah. If the smaller number of p1 and p2 is not the prime itself, then it can be broken up into the prime factor that are smaller than itself but must be greater or less, but must be greater or equal to 2. This one is the condition. Okay, and then we look for the GCD, greatest common divisor. Okay, for the greatest common divisor of two non-zero integer a and b is the greatest positive integer d, such that d is a divisor of both a and b. Okay. Okay, okay, and then the greatest common divisor, okay, denoted by GCD AB notation. GCD AB is equal to D. Okay, for example, okay, I give you another example. Okay, we have GCD 10 45. Okay, and then 45. Okay, is equivalent to 10 multiplied by 4 is plus 5. Okay, this one is Q plus R. Okay, and then 45 equivalent to, okay, we have 5. Sorry, this one is we already list out this one. Okay, goes by here na. 10 5 multiplied by 2 plus 0. Okay, okay, so far do you have any question? Is it okay? Here is we got here lah. Okay. Okay, and then let's try a bigger number lah. Okay, we have GCD. GCD for 1701 3768. Then you got 3768 is equivalent to 1701 multiplied by 2 plus 366. And then 1701 equivalent to 366 multiplied by 4 plus 237. Okay, and then 366 is equivalent to 237 multiplied by 1 plus 129. Then we got 237 is equivalent to 129 multiplied by 1 plus 108. And then 129 equivalent to 108 multiplied by 1 plus 21. Okay, continue. We have 108. Okay, is equivalent to 21 multiplied by 5 plus 3 lah. And then 21 is equivalent to 3 multiplied by 7 plus 0 lah. Okay, 0, 3. Look back, we have 3 reminder. We have common denominator of our two number. The greatest common denominator of 1701 and 3768 is the number of 3. So, okay, don't forget to do this exercise. If you go like this, 31701, you divide by 3768. Okay. Okay, this one 2 2, then you got berapa kalau ni? 3402, and then you got 366. Okay, like this. And then this one is here. Okay, and then 1071 is here. Okay, okay, and then we got 366 1701 multiplied by 4. Berapa? 1464. 1464. And then you got 7 3 2 3 7 here, and then 366 here. Okay. Do you have any questions so far for the GCD? Is it okay? Clear? Okay. Okay. This one is we have three type of GCD. How to calculate? First one, you listing all the factorization 1, 2, 3, 4, 6, 8, 12, 24 can be divided by 24. And then you create the common 12. And then this one factorization by using factorization. Okay, 24. Okay, as we list before, we can find 2 multiplied by 2 multiplied by 3 is equivalent to 12. This one is factorization. And then the last one is Euclidean factor. Later we see. Okay. Okay. This one, number one is division operation. Two is prime factorization, and then number three is Euclidean algorithm. Okay, and then for division operation, please be minded for the divisor and M for the LCM. Okay, for the LCM, this common multiple. We have multiple and divisor. Okay, for the divisor, we choose the this one 2 multiplied by 3 multiplied by 4, and then for the m for the multiple we uh, multiply by 2 multiplied by 3 multiplied by 4 multiplied by 2 multiplied by 3 lah. Okay, and then for the prime factorization number 2, we choose the minimum, and then for the LCM we choose for the maximum. Okay, this one 2 power 4 multiplied by 3 power of 1, 2 multiplied by 3 multiplied by 3 power of 2 lah. Okay, this one for GCD. For LCM, we go for the maximum. Okay, do you have any questions so far? Is it okay? Yeah. This one for the prime factorization. Okay, remember for the GCD, you choose the minimum for the ordering. You list out the prime. Okay, multiply by 3 multiply by 3 multiply by 2 power of 3. Okay, you choose the minimum 2 power of 3 multiply by 3 power of 1 lah. And then for LCM, least common multiple, you choose the maximum lah. Okay, 2 power of 4 multiply by 3 power of 1, 2 power of 3 multiply by 3 power of 2, and then you choose maximum 2 power of 4 multiply by 3 power of 2. This one for the ordering. For the division operation, you choose all, including the This one is not including the reminder. This one including the reminder. Okay. Okay, and then GCD greatest common divisor can be computed using the prime factorization of A and B. This one I have show to you. Okay, we have A, for example, 60. We have B, 54. Okay, we list out the prime for the GCD is, remember, for the GCD is the minimum, not the maximum. For the least multiple, common multiple is the maximum. Okay, 2 power of 3, 3 power of 1, 5 power of 1 is equivalent to 60. And 54, 2 power of 1, 3 power of 3, 5 power of 0 for the GCD equivalent to 6. 6. Okay, and then for the minimum, we choose here, we choose 2 power of 1 minimum. For this one is the lowest. And then 3 power of 1, 5 power of 0 is equivalent to 6. Okay. Is it okay? Okay, this one you go by using Padlet. You do this exercise by using Padlet lah. Show me in the Padlet lah. Okay, for the least common multiple, it's a positive integers of A and B is the smallest positive integer that is can be divisible by both A and B. Okay, for example, we have 3, 21. We have 3 and 7 is least common multiple. Okay, for the 4 and 6. Okay, and 5 and 10. Okay, 4 and 6. We got 2. Okay, LCM of 4 and 6 is the smallest number. All multiple of 4 and 6. Okay. Okay, what is the LCM of 4 and 6? We got 12. Huh? Okay. The LCM of non-two integers 4 and 6 is the smallest positive integer of M12 is divisible by both 4 and 6 without any remainder. Okay. Okay. We have 12 for 4, 4 multiplied by 3 is 12, 0. And then also same goes to 6, 12. Okay. This one without any remainder. And then to find the LCM for 4 and 6, we have by using the multiples, by using the prime factorization method, and by division method. We have three method that I have explained before. Okay, for the LCM, first we go by the listing multiple. Boleh baca ke tulisan saya ni? Okay, and then you go by the multiple of 4. We got 4, 8, 12, 16, 20. Then we got multiple 6, 6, 12, 15, 24. Okay, and then you got a 12. Okay, to calculate the LCM of 4 and 6 by listing out the common multiple, we can follow the given step as follows. First step is list a few multiple of 4 and 6. And then step 2, the common multiple of 4 and 6 are 12. Common. And the smallest common multiple of 4 and 6 is 12. Uh, Smallest common multiple. Smallest mean least. Okay, another than this, we have 24. As you can see here, we got 24 here. Okay, you choose the very least. They have a common. And then secondly, if you are using second way is by using prime factorization. Okay, for the prime factorization of 4 and 6. Okay, for the 4, we got 2 multiplied by 2, 2 power of 2 lah. And 6, 2, 2 power of 1 multiplied by 3 power of 1 respectively, and LCM of 4 and 6 can be obtained by multiplying prime factors rise of their respective highest power. Okay. Here we go by the highest power, which means that 2 power of 2 multiplied by highest. Okay. Okay, and then the prime factorization is 2 power of 2 multiplied by 3 power of 1 is equivalent to 4 multiplied by 3 is 12. Okay, ada soalan ke? Do you have any question? Is it okay? Boleh ke? Can you follow me? If you are not clear, please ask me. This one is very important. Okay, and then the last step by using the division method. Okay, for the HCM, okay, third one is by using division. Okay, we got LCM 4 and 6. Got 2, 4, 6, 2, 2, 3. Okay, 2, 1, 3. Sorry, 2 multiplied by 2, 2 multiplied by 3, 6. And then 3, we got 3, 1, 2, 2, 3. 2, 3, 2, 4, 6, 3, 1, 3. Or 2 multiplied by 2. 2 multiplied by 2, 2 4 6. 2 multiplied by 2 is 2. 2 multiplied by 3 is 6. Okay, and then 3, 1, 3. Okay, and the 1, 1. Okay, the LCM for 4 and 6, we got 2 multiplied by 2 multiplied by 3 is equal to 10. Okay, step 1 is find the smallest prime number that is factor of least one of number 4 and 6. Write this prime 2 and let left of the given number 4 and 6 expected by the ladder arrangement. And step 2, if any given number 4 and 6 is multiplied by 2, divide by the 2 and write the quotient below. Bring down any number is not divisible by the prime number. Okay, step 3, continue the step until the ones are left in the last row. Okay. Okay, and then the LCM of 4 and 6 is a product of all prime number on the left. Example, for the LCM 4 and 6, by division is 2 multiplied by 2 multiplied by 3. This one is prime number. Okay, then for the least common multiple, we have to choose the maximum. Okay, for example, we have A 60 and B 54. Okay, 60, 2 power of 2 multiplied by 3 power of 1 multiplied by 5 power of 1. Okay, and then for B is 54 is 2 power of 1, 3 power of 3, 5 power of 0. And then we choose the maximum. This one 2 power of 1, 2 power of 2. The maximum is 2 power of 2. Multiplied by 3 power of 3 is maximum. Multiplied by 5 power of 1 is equivalent to 4 multiplied by 9 multiplied by 5. And this one is not 9, this one is 27. Sorry. Okay, it's equivalent to 20, 514. Okay, for the exercise for GCM, find the greatest common divisor of this pair. Okay, this one you uh, go for the exercise in parallel. And then relative prime integers, we have two integers a and b are relatively prime if GCD a and b are equivalent to 1. Okay. Okay, for example, 15 and 28 are relatively prime. Yes. Okay, the GCD of a and b are 1. Okay, another example, 55 and 28 prime. Yes. 35 and 28 relatively prime. No, nah. The GCD of 35 and 28 is for the least minimum is 7. For GCD for 7 and 20. This one relatively prime or not? 7 and 20. Yes lah. Okay. Okay. 7 and 22 GCD equivalent to 1. Yes lah. Okay. Okay, if you are not understand yet, I give you another example. Okay, for example, we have 7 and 9. This one is relatively prime. We got here 1 and 7. And then here we have 1, we have 3, we have 9. The only factor is common for both is 1. Okay. This one is relatively prime. The answer is yes. Okay, another example. Okay. Boleh faham ke? Pretty, is it okay for you? Okay, we have 8 and 10. Okay, for 8 we have 1, we have 2, we have 4, and then we have 8. And then this one we have 1, we have 2, we have 5, we have 10. The common factor common for both 10, 8 and 10 and 1 and 2 lah. Which means that this one is more than 1 lah. Okay, more than 1. Okay, GCD, the minimum for A and B must be 1 lah. Is it okay? Boleh ke? Okay, another example lah. I give you another example. Okay, 31 and 36. This one is relatively prime. Okay, okay, we list out the 31. 31, we have only 1 and 31. 36, we have 1, 2, 3, 4, 6, 9, 12, 18, and 36. Okay, the answer is yes because we have only one here, common. Okay, the answer is yes. For 24 and 36, prime, relatively prime. The 24, we got 1, 2, 3, 4, 6, 8, 12, 24. For 36, we got 1, 2, 3, 4, 6, 9, 12. Okay, for this one, we have 1, we have 2, we have 3, we have 4, we have 6, we have 12. Is this one is relatively prime? The answer is no lah, because we have more than one. Okay, 24 and 36 are not relatively prime because if the only common factor is 1, the number are relatively prime lah. Okay, but here you can list out, we have how many here? 2, 4, 6. 6. Okay, same goes to 15, 17, and 27 pairways, relatively prime. If GCD AI AJ is equivalent to 1, whenever 1 is less than I, less than J. This one is if we have 3. Okay, 15, 27, no lah, because for the 15, 1, we have 3, we have 5, 15, 17, we have 27, equivalent to 1, 3, 9, and then we have 27 lah. Okay, we have 1 here. Okay, and then we have 3. Okay, we have 1, 2, 3, 4, 5 lah. Okay, 1, 2, 1, 3. Okay, we have more than 1 lah. Because GCD 15 and 27 is 3. 1, 3, 5, 7, 9, 5. Okay, we have 3 here. Okay, 15, 17, and 28 pair prime. Yes, 28. Because GCD for 15 and 17 is 1, GCD for 15 and 28 is 1, GCD for 17 and 28 is 1. Okay. Okay, for this one, you are required to submit in your Padlet. Also for this one. Okay, and then for the relationship between GCD and LCM, for the GCD, we are looking for the minimum. For the LCM, we are looking for the maximum. Okay, and then for the theorem, A multiplied by B, 60 multiplied by 54, GCD A, B multiplied by LCM is same. Same. Okay, same output lah. And then for the Euclidean algorithm is the find the greatest common divisor of two integers A and B. For example, if you want to find the GCD 287 and 91, we divide the largest 287 by the number 91, the smaller one. This one I have shown to you. Okay, we have 287 equivalent to 91 multiplied by 3 lah. Okay, like this. 91 multiplied by 3. 273. 14. Okay. And then here we got 14. We know that for the integers a, b, and c, if a can be divided by b, then a also is can can be divided by b multiplied by c for all integers c. Therefore, any divisor of 91 is also divisor of 91 multiplied by negative 3. Okay, 1, okay, by 3. 3 or negative 3. Okay. Okay, we also know that for the integer a, b, and c, okay, a is divisor, b is 287, and 91 must be a divisor, which is 14. Consequently, the greatest common divisor (GCD) of 287 and 91 must be the same as the greatest common divisor of 14 and 91. So, in the next step, we divided by 91 by 14. Okay, 91 by 14, and then we got 14 and 7. Okay, then so we divided 14 by 7 until the remainder is 0. So the GCD of 287 and 91 is we got 7. Okay, 7, because the remainder is 0. Okay, same goes to here. We have until the last divisor is GCD and the remainder is 0. Okay, okay, we divide like this: 2875 divided by 4915. 1 is okay, the remainder. And then here is the divisor. We go by the here until the remainder is 0. And then we got the last one is the GCD last divisor GCD here. Okay, same goes here. Okay, equivalent to 5. Okay, the Euclidean algorithm for the GCD, this one we can also use this theorem. Okay, 2875 multiplied by 4915 divided by 5 is equivalent to 2,826,125. Okay, this one is we got 24, and then and here we got 144 lah, for the minimum and maximum lah. And then the Euclidean algorithm, we have a dividend larger and then divisor is smaller. Okay, and then here the formula is equivalent to A, equivalent to the divisor Q plus R. This one I explained earlier. And then the last divisor is the GCD until remainder is 0. Okay, same goes here. Okay, the remainder GCD is 111. And then for the LCM, okay, for the LCM, we divide by the GCD, and then we got 158,730. Okay, for the greatest common divisor, 450, 414, and 662. Using the Euclidean algorithm, okay, finally we got GCD is 2, because 2 is the last non-zero remainder lah. Okay, for GCD A and B, GCD B and R, we can be done using the computational programming. Okay, this one we use the pseudocode, can be implemented as follows. This one we initialize. Okay, this syntax is modulus. Okay, please use this exercise in Padlet. Okay, please be reminded you need to find the reminder 0, okay, for the GCD. For the LCM, okay, please divide by the reminder. Okay, this one is Bizot theorem. Bizot theorem is the positive there exists integer s and t such that GCD A and B is a plus t and b. Okay, we got for the s, okay, and then for the t, okay, and then s is here 5, t is here 59. Okay, in mathematics, Bizot identity, also called Bizot lemma, named after the n-time Bizot, is the following theorem. Uh, Let A and B be integer of polynomial with the greatest common divisor dA, then there exists integer of polynomial x and y such that ax plus by lah. Okay, this one is example linear combination. Okay, linear combination of this integer. Please use this one in Padlet exercise. Okay, this one is the answer. Okay, for the result identity, can I explain to you? Okay, example one. We have GCD equal to 4. Then here 4 multiplied by plus 16 multiplied by equal to 4. Sorry. So we have to find the result coefficient. What is 4 times something plus 16 is equivalent to 4. Okay. I can put here as 5. Okay. 5 and minus -1. Okay. because this one is okay, 16. So this is a wizard identity lah. This one we call it as wizard identity. Wizard identity is how can we find it well, okay, through a method or algorithm that we call it as extended Euclidean algorithm. Okay, this one is we call it as wizard identity. Okay, same goes here lah. Okay, one SA plus TB, we have 1,221 and 144,000. Okay, for this one is multiply by 4 lah. Okay, we got 181, 111 for this one. And then for this one, for wizard entity, 999 minus 4. Okay, uh, 1221 minus 999. And then 999 minus 4, 5. Okay. Okay, this one is wizard identity. We got the final one is 111. Okay, this one is 5. A, T is 59. B, this one is wizard identity.